Okay, so we talk all the time about making our power grid green, right? With renewables and all that. But it turns out there's another kind of clean that's just as important, keeping the electricity itself pure. Today, we're going to pull back the curtain on an unseen pollution that can literally clog up our grid and explore the super clever ways engineers are cleaning it up. So picture this. The electricity that powers our entire world is supposed to have this perfect, elegant shape. It's meant to be a beautiful, smooth sine wave, humming along at a steady 50 or 60 hertz. That pure waveform, that's the gold standard. It's the foundation of a healthy, efficient power grid. But what happens when that perfect wave gets distorted? When it gets junked up with a kind of electrical static? Well, that's where things get really interesting.
All right, so what is this pollution we're talking about? Let's get right into it. We're talking about something called electrical noise. Probably the best way to wrap your head around this is with a music analogy. Imagine that perfect sine wave is a pure, clean musical note, like a single key on a piano. Well, harmonics are like someone slamming their hands on a bunch of random, clashing keys at the same time. The result isn't music anymore. It's just noise. Now, for the more technical bit, harmonics are basically these unwanted extra waves that have frequencies that are multiples of that main 50 or 60 hertz frequency. And here's the bottom line. They piggyback on the main signal, distorting that beautiful, clean wave and seriously degrading the quality of our power.
So where does all this noise even come from? Well, it comes from the stuff we plug in. On one side, you've got your old-school linear loads. Think of a simple toaster or a heater. They're well-behaved. They draw a nice, smooth current. But then on the other side, you've got nonlinear loads. And these guys, these are the troublemakers. They sit power in these choppy, distorted bursts, and in doing so, they inject all that noise back into the grid.
And these noisemakers are absolutely everywhere. I mean, look around you. We're talking about our computers, our printers, all our modern LED lights, every battery charger you own. Basically, any gadget with modern electronics inside is a nonlinear load. They're in our homes, our offices, our factories, you name it. And this is not just some abstract idea on a graph. This electrical noise has very real, very physical consequences. It makes equipment and wires overheat, it can cause complex machines to misfire, and it can even create these damaging vibrations in big motors and generators. So yeah, this invisible pollution causes very visible and often very expensive problems.
Okay, so we know what this noise is, but here's where the story takes a really fascinating turn, because the biggest sources of this problem might not be what you think at all. I mean, with all of our gadgets, it makes sense that harmonic distortion is on the rise. But what are the biggest culprits on a massive scale? You know what? The answer is kind of ironic, actually. You heard that right. One of the biggest sources of this noise is our big push for green energy. Huge solar and wind farms, they connect to the grid using devices called inverters. These things are absolutely essential, but they are also massive nonlinear loads, pumping a significant amount of harmonic noise into the very grid they're supposed to be helping. And culprit number 2? The push for green hydrogen. Turns out, the most efficient way to power the massive equipment needed for this process creates a ton of harmonic distortion, too. So get this, the very technologies we're counting on to clean up our atmosphere are, in a way, creating a new kind of electrical pollution for the grid. But hey, this isn't a story about doom and gloom. Not at all. It's a story about clever solutions. Engineers are not just sitting back and letting this happen. They've developed a whole toolkit to fight back. So let's meet the grid's cleanup crew. They're coming at this from all angles with a kind of 3-part attack plan. First, they can filter the noise out. Second, they can get really clever and cancel it at the source. And third, they're using artificial intelligence to diagnose problems faster than ever before. Let's break each one down.
All right, strategy number 1, filtering. To do this, engineers use these smart devices, like something called a StatCom. The best way to think of it is basically a giant pair of noise-canceling headphones for the power grid. It listens to the distortion and actively creates an opposite signal to smooth everything out. And wow, does it work! Check out this chart. It's showing something called total harmonic distortion. Before they turn the StatCom on, the distortion is at 3.2%. Not terrible, but not great. But look what happens when they flip the switch. It absolutely plummets to just 0.38%. Basically, the noise just disappeared.
Okay, the second strategy is, if you ask me, even more elegant. Instead of just filtering the noise, what if you could make the noise cancel itself out? It's a brilliant approach that uses the problem to create its own solution.
Here's how it works in that green hydrogen plant we mentioned. So they have two of these big electrolyzer units. What the researchers figured out is that if they run one at a slightly different current than the other, the harmonic noise they each create becomes a perfect mirror image. It's equal in strength, but exactly opposite. So when those two signals meet up on the grid, poof, they cancel each other out. How cool is that? It's just incredibly smart engineering.
And that brings us to the final strategy, which is all about speed and precision. See, when a power quality problem pops up, you have to figure out what caused it, and you have to do it fast. And that's where AI comes in, acting like a super fast detective for the grid.
What you're looking at here is pretty much a report card for an AI. It's called a confusion matrix, but all you really need to know is that bright diagonal line means the AI is getting the right answer every time it's tested on different grid problems. And as you can see, this AI is getting straight A's.
And the numbers totally back it up. The top-performing model here reached an accuracy of 97.5%. That is just incredible. It means grid operators can figure out what's wrong with unprecedented speed, stopping small problems before they become massive outages.
So, okay, we've got the tools. We know how to fix this. But having the tools is one thing. Putting them to work and making sure everyone plays by the rules is a whole other challenge. Let's bring this all home.
Because look, this stuff is actually regulated. It's not the Wild West. There are standards, like this one called IEEE 519, that are like the rules of the road for the grid. They set strict legal limits on how much harmonic pollution anyone is allowed to create. For most grid voltages, for example, that total harmonic distortion has to stay below 5%. It ensures everyone connecting to the grid is being a good citizen.
And that really leaves us with the big question, right? As we're all pushing for this greener energy future, we have to keep asking ourselves, how do we make sure the power that runs through it isn't just green, but that it's also clean? That's the challenge, and it's one that some of the world's best engineers are tackling head-on.